Section 8.6 is called transversals. So transversals is the line that intersects two other lines at the same time. So in this case, we have line A and we have line B. Line C is a transversal because it's intersecting two of the other lines. Okay, based on these intersecting lines, we also have different types of angles created. So we have corresponding angles. They have the same position. So like angles 1 and 5 are corresponding because they're both top left. 2 and 6 are corresponding because they're both top right. 3 and 7, both bottom right. 4 and 8, both bottom left. We also have alternate interior angles. So alternate means on other sides. Interior means on the inside. So we have angles 4 and 6 are alternate interior angles, and 3 and 5 are alternate interior angles. We also have alternate exterior angles. Alternate sides of the transversal, but on the outside of the two lines. So we have 1 and 7. 2 and 8, and last but not least, we have what's called consecutive interior angles. So consecutive means same side, interior, inside. So 4 and 5, 3 and 6. Then, based on those special angles that we talked about, if those lines A and B are parallel, and we know that those are parallel because you see this little one mark and one mark right there, that's going to indicate that they are parallel. We know that the corresponding angles, alternate interior angles, and alternate exterior angles are congruent, and that the consecutive interior angles are supplementary. Then you know if one transversal is perpendicular to one of the two parallel lines, and it's also perpendicular to the other. So here's example 1. What we know is that line M is parallel to N, and so I'm going to mark it by using these arrows. So now we know that those are parallel. We know angle 1 is 5x, and angle 6 is 2x plus 19. So I'm adding that to the diagram. Again, geometry, always label your diagrams. So angles 1 and 6 don't share any relationship with each other, but what we do know is that angle 4 and 6 are alternate interior angles. So we know that these two angles have to be the same. So I'm going to label right here at 4, 2x plus 19. Now looking at the relationship between angle 1 and 4, these are a linear pair, meaning that they add up to 180. So now I can do 5x plus 2x plus 19 is equal to 180. I'm going to have 7x is equal to, what's 180 minus 19? 161. And if you divide both sides by 7, you're going to get x is equal to 23. So if x is equal to 23, we know that this angle, 5 times 23, is 115 degrees, and that makes this other angle 65. So what we can do now is label in our answers, angle 1 is 115 degrees, and angle 4 is 65. If angle 4 is 65, you know 2 is also 65 because they're vertical angles. Add that to my label. If 1 is 115, 3 is 115. 3 and 5 are alternate interior angles, so they're the same. 4 and 6 are alternate interior angles, so they are the same. 6 and 8 are vertical angles. Same thing with 5 and 7. So you use a little bit of information that you're given and then just keep branching off of it. All right, example number 2 is a little bit more difficult. We know that angle 7 is 55 degrees, so I'm going to label that. And I'm also going to label it here. If 7 is 55, then we know 5 also has to be 55 degrees because they are vertical angles. Okay. What we also know is that this line is perpendicular to this parallel line, which means it also has to be perpendicular to this one. So that makes angle 6 90 degrees. Now what we know, if angle 6 is 90, this angle right here also has to be 90, so this angle right here has to be 35 degrees. Okay. What we also know is that angle 5 and 1 are alternate interior angles, so 1 is 55 degrees, that makes 3 55 degrees. And we know that these are a linear pair, so 2 has to be 125, and that also makes 4 125. Angle 8 also has to be 90 degrees because it's vertical angle to angle 6.